Welcome to the Primary Science Podcast. We've made it into the materials unit. So once again, I've been granted my wish and have some brilliant guests to help make this unit feel nice and easy to teach and really, really fun for the kids. First up, very excited to introduce David Allen. So Dave, would you be able to just tell everyone a bit about yourself and what you've been up to recently?
Hi, Tim. Yeah, it's great to be here. As Tim said, my name's Dave, and I am a university lecturer. I'm an associate professor at University of Hertfordshire. I do that part-time. I train primary school teachers. I'm also a consultant, educational consultant, and I've just set up a company. Jules, who's also on the call, we've set up a company called Let's Do Drama, and I think there's going to be an episode all about that in the future. I'm also this year the chair of the ASE, the Association of Science Education. So we had our amazing conference in January. And as you can imagine, that was quite busy doing talks and awards and speeches and stuff. But that was amazing. It was a brilliant experience. Outside of work, I'm doing lots of outdoor swimming in a pool, not while swimming, not up to that. And I'm still doing lots of baking cakes. So that's my thing.
Super happy to have you on the show, Dave. And I can't wait to hear more about Let's Do Drama.
Thank you. It's good to be here.
And our second guest, everyone, is the one and only Jules Pottle. So, Jules, we would love to know just a little bit more about you.
Hello. I'm still teaching, so I've got a year 6 class at the moment, a couple of days a week, which means I'm on residential. I've got SATs coming up, all of those things. But because it's part-time and I do other things as well, I'm directing storytelling schools. So that involves a bit of travel, going to Malta, working with some schools out there, and teaching online and teaching around the country here as well. Teaching teachers to use storytelling to teach English, but also history, science. So I'm sort of science through story lady. I've got another book on the go for Great Science Share for 2027. So watch out for that. And I'm also working with a friend. So in my local village, I do quite a bit of drama with the local panto. And one of my very best friends is a puppeteer. And I'm doing some research into the effect of theatre shows on the very young, because these are theatre shows for SEN and the under 5s. So that's an exciting little project as well. So look, too many things really, to be honest, but yes, all fun.
Well, welcome to the show, Jules. And I absolutely cannot wait to get all your ideas about teaching materials. And then, ladies and gentlemen, our third fantastic guest is none other than Paul Tyler. How are you doing, Paul?
I'm really good, Tim. Delighted to be asked back for this one on materials, which is one of my absolute passions. I am a primary school teacher. I'm not currently in the classroom. I'm currently working for a charity called SmartSTEMS, based up here in Glasgow, but working UK-wide. And our focus at SmartSTEMS is about connecting industry and schools and showcasing to children the kind of wide range of careers that there are across the STEM disciplines, and what the different pathways into those careers can look like. So at the moment, I am working on projects around dairy farming, around air quality, around nuclear reactors, around CCTV, around rail safety. It's really exciting. I get to go out to these industries, talk to people about what they do, the processes they use, and then think of engaging ways to tell those stories to primary school children predominantly. So it's absolutely brilliant. I am also the chair of ASE Scotland this year, a role which I'm really enjoying. And I'm also the co-founder of My Science Club. And we produce resources to support educators running their own science clubs in schools. So very like Dave and Jules, I do far too much to fit into the time that I have available, but absolutely love all of it.
Brilliant. Well, welcome back to the show, Paul. And every time I hear about all the different things you're doing, I just think you have such an interesting life. And I wish I could do half of those things, to be honest.
Thank you. That's one way of putting it. I think my family would put it another way, but...
Okay, so I think we should get straight into it. So if you teach year 1 or year 2, the aim of this episode is quite simple. you should be able to listen to what we have to say, gain those insights and ideas, and then just take them straight into the classroom next time you teach materials. So we're going to start with year 1, where, of course, it all begins. We'll be looking at things like objects versus materials, naming different materials, looking at simple properties and grouping things together. So there's loads and loads of great opportunities here to build those science skills as well as learning the concepts. So Dave, I'll come to you first. If you're starting the materials unit with a year 1 class, say, on a Monday morning, very first lesson, what's the first thing that you're going to do with them?
I think the most important thing that I do first is to make it hands-on. I think that would be really, really vital. And with the materials, I'd start off with wood, probably. I'd pass around offcuts of wood, bits of branches. And like you said, we'd start talking about where these things come from and make the connection with trees that they know. We'd then move on to think about wooden objects that they know that are made from wood. So things that they use all the time, like toys. And then we'd start talking about the difference between the object and the material and make that distinction, which is, it can be quite hard for some children, but keep repeating that and talking about the difference between the object and what it is made from. Then we'd introduce the fact that it's natural. Wood is a natural material, so talk about that with the children. But I think one of the most important things is a topic called everyday materials and making that link with what is the connection with their everyday life. Materials are part of our lives, and teaching science is all about that, isn't it? Making the connection between the subject in the classroom and what it means to them outside of school. So look around the classroom and what things are made of wood in the classroom and what do they use and play with that's made of wood. And then think about what all those things have in common. They're all made of wood. So we start to be sorting things into a group that are wooden objects. This lesson's probably quite a long one. It might be more than one lesson, to be honest, but I'd repeat that then with metal objects. And then we'd start looking at observable properties, thinking about what we can see. So we think about the texture, what we can feel, the colour, the weight and the temperature of the object. Once we've done that, we then move on to plastic objects and think about what's in the room that's made of plastic. And then I'd introduce the term manufactured. And then we look at the difference between natural things and manufactured things. And the children will be using those observation skills to help them identify different materials that are in the classroom and then sort them into those 3 groups. So it probably, I would imagine that's probably going to be all morning, to be honest, but I think that's a good basis to start with to get them to understand 3 materials that they have experienced in the past and now they know a little bit more about them.
Yeah, it's all about play, right? These are your toys. These are things you love that you play with every day. I think even though it might take a whole morning, the kids are going to love that. For them, it's playtime with, sorting involved.
Yeah, absolutely. And that's what learning is about, isn't it? It's making sure the children have got hands-on experience and they're seeing that it's relevant and it's things that they're using and they know, and they're just learning more about it from a scientific point of view.
Thank you very much, Dave. And over to you, Jules. Now, there's a lot of vocabulary in this unit, as Dave alluded to there. And for some children, some of it is completely new. Rough, smooth, waterproof, for example, especially for EAL learners. So how might you build that language in naturally without it sort of turning into a bit of a science spelling lesson?
Yeah, well, the word was there, play. We need it to be as playful as possible. And playing with the language is really important too. So you have to create a scenario where that language is important. And sometimes that can come from a story, but often it can come from, like, you give the children a sock. You put it on your hand, it becomes an alien, and you need to model it well. But once you've got this alien to talk to, you can then explain what things are. You can go, well, what's this? Oh, this thing is made of plastic. It's called, a pencil sharpener or whatever, but it's made of plastic. Oh, where does plastic come from? And you model having a conversation between you and the alien, and then you get one of the children to be the alien and one of the children to be the explainer, and give them a chance at explaining around a tray of toys that you've put in the middle of the desk for them to explore. But as with all things, if you're playful with it, that's when the questions come out. So if you give them a chance to play, just like Dave said, that's when they go, well, why isn't this the same as this? Or what's this made of? This is another thing entirely. This isn't any of those things. What's this one? And that's where the questions come from, is if you just give them a chance to explore and to play. So play is really key. And then being playful with the language too. If you have EAL or SEN in your class and you want to make sure that those words are really stored correctly, then I would do a kind of talk game with them first where we practice it. So this comes from storytelling schools, and you put an action to all these things. So if it was waterproof, I might put up, have an umbrella or a hat that, I'm doing the action for, so I'm put up my umbrella and I'm underneath it, and that's waterproof. And we all do the action, we all do the word, just to rehearse those, and then go into the free talk game where you're talking to the alien and explaining to them, something like that.
And over to Paul now. I think every year one teacher at some point has done some version of a materials hunt. Dave was saying, let's go and find these toys made of wood, made of metal around the classroom or school. How do you keep something like that scientific? Like, of course, while it's during play, but how do you keep it scientific so they're actually doing that, observing, that comparing?
I think the key, and Dave talked about this, the key is focusing on the materials and not the objects. And normally you'll find when you start this with kind of year one children that actually they will focus on the objects rather than the materials. And they will start to, if you're doing a grouping activity, they'll start to group things by what the objects are, rather than the materials. So it's always bringing it back to the materials. This used to be one of my favourite things. And I used to take my classes out around the school on a school walk, and each pair of children or each small group would have labels with wood, metal, plastic, glass written on them, and they would have a little blob of blue tack. And we would see how many things around the school we could cover in labels of what the material was. And the idea was that, we would try and sort of plaster the school with as many labels as we could of what the material was, to then get other children to question what we'd been doing. So we were looking for, objects made of metal. And it was a brilliant one to do kind of first thing in the morning, because at first thing in the morning, everything that's metal is really cold. So as Dave talked about, that importance of using the senses, things that are metal are often shiny. They're also cold. So getting the children to use all of their senses. I used to let the children as well take a metal spoon with them, and we would tap things, because metal sounds different from wood, sounds different from glass, from plastic. So getting them to use all of their senses as they're exploring, but always bringing them back to the fact that you're looking for them to think about the material, not the object. So once we've plastered the school with our labels blue tacked onto everything, I'm then looking to come back to class, and I'm maybe looking for groups, small groups, sitting around a tough tray with a lot of different materials in the middle, and they are discussing in groups, how they're going to sort those, and really sitting with them, working with them, asking them questions, and getting them to sort things into the materials that they're made of. And I would always carefully select the materials to start with, so that they're objects that are made of one material. So I've not got toy cars in there which have got a mixture of metal and plastic. I've got metal spoons, I've got wooden building blocks, I've got a plastic ruler, I've got a metal ruler. They are objects that are made of just one material. And so we can really have that discussion at the start about the material rather than the object. And I think once they get that confidence about talking about the material, you can then start to introduce objects that are made of 2 materials or 3 materials. You can start looking at the Lego, and how the Lego is made of plastic, but some of it's made of rubber. And the plastic, can be clear, or it can be coloured. So I'm really wanting them though. And all the activities that I do at this stage are getting them to talk about materials, not objects. And I think that's the key bit of learning that you want to come out of it.
And if I could go back to Dave for a sec, investigations, like we've been saying in year one, they can sometimes, for a lot of teachers, feel a little bit risky. There's a lot of unknowns. And so things like asking questions about the best material for an umbrella, or the best material for a raincoat sounds great at first, but if you don't do it right, it might go off the rails a bit quickly. So what might a really good, simple test look like at this age?
First of all, love a scenario with children because it really does engage them, keeps them focused, gives them a purpose. So like you said, we need a material for a teddy bear's coat to keep them dry when they go outside in the rain. Teacher's umbrella's got a hole in it. What we're going to use to patch it. We're going to make an apron for art. What sort of material would be best? So the children are engaged because they know the purpose. So it would be quite teacher directed, and I think that's fine. It's year one. And it's all about developing their work scientifically skills at this stage, even though you're helping them to set up the investigation that they're going to do. So I would give them a selection of fabrics and papers, maybe 10 different ones to choose from, give them squares that they'll cover the top of a small clear beaker. And I would very much model this to show them what they're going to do. And you want samples out of those 10 that some are going to not let water through. They're going to be waterproof. Some are going to soak up the water, so they'll be absorbent. And some of them will let water through. And those are not waterproof. So I'd model to the children adding the water to the top and how many drops they're going to use with a pipette. And I'd put food colouring in it, something I did more recently when I was working with children, because it helps them to see the movement of water through the different fabrics, or not, as the case may be. So I'd be saying to the children, you need to choose 4 materials out of all those papers and fabrics that are there. Just choose 4 and place a sample in turn on top of the small beaker, and the water dropper will be used to carefully drop the water onto the sample surface, and then talk to them about how they're going to record that. So they're going to be selecting, they're going to be observing, and they're going to be recording and using equipment, but very much for a real life context. And then posing those questions to them at the end. How will you know which materials let water through and which do not? And then which materials did stop the water going through? Which materials soaked up the water? Which materials that you haven't tested do you think that might be waterproof? And what makes you think that? So yes, it's teacher directed, but the children are going to gain some real learning and understanding from it, and they're still developing their working scientifically skills.
Thank you, Dave. And I wanted to ask Jules as well, is there a way into this unit through a story? I know you mentioned before about stories, maybe drama or a real life context, so it feels, really meaningful.
Absolutely. I teach even all the way up to year 6. I still use stories with the children because it makes it meaningful, makes it feel more real, and they can imagine as they're hearing the story where all the science fits in if you have it built into the story already. But year 1, my favourite book for materials is always going to be Traction Man. Have you seen Traction Man by Minnie Gray? It's about an action man figure comes in a box and he has all the different outfits. If you were born in the 70s, like me, and you had Barbie dolls and Action Man dolls, and they all came with different outfits, and all his different outfits in this book are for different adventures, and he's always very conscious of what he's wearing. And then Granny knits him a woolly outfit, which he hates. And so this is a great way to go, right, here are all these different fabrics and what are they suitable for. So deciding whether you're going to have the waterproof outfit that he's going to wear when he goes out, or whether he's going to have the one that lets the heat in or the heat out. These are things that you can measure as part of their tests. So it ties it all together. For younger children, I also use a story called A Wongalima. There are lots of copies of it on the internet. A Wongalima is all about some animals, and the animals are very hot and under a tree, and we look at shade, which ones create the best shade, shining a light through the same pieces of fabric, and that story can work for which of these would keep the animals dry, so that you can kind of use a story for lots of different things. Even Cinderella is a good one for this one, working out which is the best material to make a coach from so that it's waterproof, it stands up tall. So you can link it all to a story in that way by finding a story that has lots of different scenarios that need lots of different materials.
Thank you. And I'd never heard of Traction Man before.
Oh, you've got to read it. It's a brilliant book. Minnie Gray.
Okay. Thank you. Okay. And then over to Paul. I'd also love to, just for a minute, talk about science capital with you. So materials are obviously everywhere. So how do we sort of tap into that
And one of the things you quite often find about materials at this level is that a lot of the children sitting in front of you, they actually have the knowledge, they have the answers, and it's about eliciting that from them. They'll be able to tell you why a window is made of glass and not made of wood, and it's just eliciting that from them. I suppose making them think about the sort of scientific value of that piece of information. I would always constantly reference where children can find these materials at home, where they use these materials at home and out about in the world around them. Dave's already touched on the importance of children or building an understanding over time of where these materials originate from, where they come from. And that starts with wood, which is the most sort of obvious, and because you can take a piece of wood from the classroom, whether that's a pencil or a wooden ruler, and you can go outside and look at a tree and you can see directly where that where the wood for that object has come from. It's a little bit more challenging with the other materials, but as children go through their school life, I would want them by the end of primary school to have a pretty good idea where plastic comes from, where glass comes from, and really understand the kind of manufactured versus natural bit of that. But if you can encourage children to look at the material that their clothes are made of, how their school jumper is made of a different material to their school jacket. So having that understanding from a sort of scientific point of view about why those materials have been chosen for that object or that application, I think is really important and really brings the relevance to everything you're talking about.
Yeah, thank you, Paul. I'm glad that you mentioned the materials and their properties there, because now as we move on into year 2, we already assume some knowledge, at least, that the children have been through what the materials are and some of their basic properties. But now we're really starting to go into a bit more depth about suitability. So, Dave, if you had to choose one really awesome, solid investigation for year 2 around suitability of materials for uses, what would you go for?
Well, this one is one that I've done more recently. And again, it's back to children's experience and real life relevance. So I would talk to them about needing to choose fabric for a pair of toddlers' dungarees. So it might be they remember being a toddler because it's not that long ago, potentially, or it might be they have younger siblings who are a toddler, so they're going to have that experience. But they know, you talk to them about the fact that that fabric is going to need to be durable. It's also going to need to be strong, but flexible. And then you talk to them about, well, whereabouts in the dungarees is important. And you talk to them what toddlers do. They scoot round on their bottom. So it needs the seat of the dungarees needs to be really, really strong, and the same for the knees. So you talk to them about doing a comparative test, and children at this stage are going to be doing more investigation. So you talk to them about looking at different samples of fabric. And again, you'd model wrapping those around a hand-sized stone and then model rubbing vigorously and gently onto a brick. And then talk to them about what they're going to need to do to see the durability of that fabric. So you're going to tell them they're going to need to check how hard they rub, how far they rub, and count the number of rubs. And then to be really observant and notice when a hole or holes have appeared in the fabric, and then talk to them about how they want to record and share that. Maybe you've gone into role and talked to them as a manufacturer of toddlers' dungarees, and they're going to perhaps explain to that manufacturer in the end which fabric they found that the manufacturer should use when they're making toddlers' dungarees.
That actually sounds really, really fun. What did you find out? Have you got any answers, or must we find out for ourselves?
Find out for yourselves, but I think there's a good reason, and Jules is a good advocate for this. Denim dungarees are a pretty good bet. It's really interesting because the children do get really engaged, and it might be you might know a toddler, get them in to model what sort of dungarees they're wearing. But I think, again, I keep harping on about this, but making it relevant to real life, and it comes back to what Paul's saying about Science Capital. Then they can see the point. They know we should be doing that all stages of science, to say, you know what, why are we doing this? Well, we're doing it for a reason, because you need to know, and it's relevant to your life.
We've heard some great ideas already on inquiries we can do, but I think sometimes if you don't look at the unit as a whole, this might start to become a little bit, for want of a better word, a bit bitty. There's just so many options, so many materials that we can look at. Is there a way that we could sort of keep it feeling like one clear learning journey, perhaps?
Yeah, this is part of what I do for my life, is finding the perfect story that does the whole topic. And that is a challenge, actually, for stories that are already in the world. Finding one that covers exactly what you want for your science topic isn't necessarily an easy job, but there are a few if you look at them and then extend them. So, for example, Traction Man is my favourite. I'll always go back to that. And you can have Traction Man, he goes on an adventure in the sandpit and goes over all kinds of obstacles, including a cheese grater. So there's ways of sort of making your experiment reflect that. So it could be an outfit for Traction Man rather than a child, and it's rubbing over the rough surfaces. Exactly the same experiment, just slanted slightly differently. But of course he goes off on lots of different adventures. But there are other stories where children go off on an adventure to somewhere cold or to somewhere wet. So there's lots of stories like Lost and Found. He's off on his own doing something. You could even do it around The Owl and the Pussycat Went to Sea. There's a whole load of, you need to find something where there's a range of different fabrics in it, or could be in it if you extended it. But equally, you can do it in the context not of dungarees but of a bag. So you could test out what bag is good for carrying, and then that bag can belong to a different story. So you can have the lighthouse keeper's lunch, like the basket that goes across on the wire, different things to go over the top, different things to hold the weight. So depending whether you're looking at the strength of it or whether you're looking at the waterproofing of it, and then you could look at different things inside to pad it. Look at the stories you're already using and celebrating in your classroom, and then look at the objects in it that are useful, such as clothing or bags or outerwear or umbrellas or boats, and then start using the testing to reflect the materials that are in the story. So is that helpful? It makes it generalized, but that is what I spend my life doing, is going, oh, okay, where's the materials in this? What could I do? Thermal insulation, I could do wrapping up things in that. Can I get my hot toasted sandwich or a boiled egg still warm all the way across in the basket by wrapping it up in different fabrics, looking at that, as well as keeping it dry, as well as lifting the weight.
Yeah, that's really helpful. And stories are something that kids almost naturally always love and they're familiar with. So yeah, is there a list somewhere, or is there sort of a bank of these stories and their matches?
I've created lists. One of the best places I've gone to, but I'm not sure if you can still get into it now, is St Mary's, Twickenham. They have a Padlet with a whole load of science stories. There are people who put them together, but sometimes finding the story requires you to have taught the subject. And sometimes they're put together by an English leader who goes, oh, well, that's about a science thing. So you need to check them for yourself that there is actually what you need in the story. But there are lists out there online that you can go and find, like Literacy Trust.
So still with year 2 here, we're looking at changing materials. So the children, they start bending, twisting, maybe breaking stuff too, which is something they tend to be experts at in a way. What practical activities work really well here?
I think this is, again, going back to that science capital, this is something where children bring a lot of kind of prior knowledge. And so you can open up, letting them tell stories of things they've broken, and why they broke, and what might have been a better material. Doing bend tests with different materials, so giving them wooden strips, a metal ruler or a metal rod, and plastic strips, and just let them have a go at bending them. What can they bend? What can't they bend? What happens when they bend it? Does it spring back into shape? Does it deform it? I would usually have this in a classroom as an activity, possibly set up in a tough tray, little task cards where the children can go to. There would be times where, as the teacher, I would be there to facilitate that activity, to be asking them questions as they were doing it. One of my favourite ones to do is wrapping different materials around a pencil and seeing what happens to them. So you can wrap a piece of string around a pencil and what happens when you take the pencil away, or you can you can get those kind of long, thin wax strips. You can wrap those round. You can get a thin piece of wire, wrap it around a pencil, and what happens when you take the pencil away. And that's a really nice way of, showing children different ways that materials react when they are twisted and bent out of shape. There's a whole range of things you can do around that. And then I think probably slightly less practical, but getting them really talking about this as well. I love the idea that you can have a career breaking things. You can be a destruction engineer, where your job is literally to test objects to destruction. Any children who've ever visited an IKEA store will know that in IKEA stores they have the chair with the machine that is constantly pushing down. I think our store in Glasgow is up to around about 20 million, presses now, and the same chair is still going ever since the store opened. There are YouTube channels dedicated to destroying things and, putting things under so much pressure to see what happens to them. And they are, although they're not hands-on practical, because a lot of them you wouldn't be able to do safely in the classroom, they are fantastic little starters or, finishing up activity. Let's watch this video of, this box of crayons being crushed and what happens to it. So again, it's linking it back to real world applications of why do we need to be able to bend and twist and stretch materials. Practically, you can do things where they are trying to squash a wooden block versus trying to squash a blob of shaving foam or plasticine. And so that mixture of hands-on things that they can do safely versus showing them things that they can't do safely, but they're actually really important applications of being able to bend, twist, stretch and squash different materials and how those materials react in those situations.
Looking at working scientifically now and focusing on the skills, are there any sort of simple routines in year 2 that could help build those scientific skills across the unit?
So, as with all things, you want them to be coming up with questions. So you need to play with stuff in order for them to go, why does that happen? What about this? What happens if? You also need to be building up their ability to test their own things. So following instructions, setting up their own equipment carefully. Those are key parts of it. So designing your experiments to be simple enough to be independent at year 2. So something very simple like testing the strength of a material by cutting a whole load of strips for them, and they take the different sorts and they loop it underneath a bag of apples and they lift it up, and if it breaks, it's too many apples. And then you try with less apples and so on. You work out how many apples each strip will carry. You can do it with weights, but I avoid doing it with weights on account of it might drop on their foot. So we tend to do things like that, kneeling on the floor, having it in front of us. But one of the main things for me is partner talk, because partner talk engages. It says everybody here has got to have an opinion. And if you use partner talk well, you can get them really engaged in what's about to happen. So I don't know if you've ever seen a street performer, and they spend an awful lot of time getting a crowd round, and then they do the trick for a very short time. But everybody's listening and waiting for that trick. They didn't do the trick and let people walk past. They made sure everybody was looking. And there's a sweet spot. You can gather people over and go, I'm going to do a thing. I'm going to do a thing. It's going to be the greatest thing on earth. It's going to be brilliant. And if you keep people waiting too long, they go, I can't be bothered now, and they walk off. And the same with children in the classroom. Their attention walks off. You have to kind of get them to want to be part of it. So first thing is to get them to commit. What do you think is going to happen? I've got a ball, a really big, heavy ball of, let's say it's a metal ball bearing, a really big one. And underneath are different types of material. And we're going to drop it on them. What do you think is going to happen with this one? Do you think if I drop it, it's going to make a difference? Okay, talk to your partner, make a commitment. Okay, and now you're going to show me your commitment. You're going to tell me the ideas you've had with your partner. So everybody's had a moment to commit to their partner, their idea, then they commit to each other, then I do some more talk, and then we have another revote, and then when they're all desperate to know, that's the point at which I go, oh, what about if I do this ball and it's a different ball, this one's much lighter, and then so they're really starting to think about how heavy the ball is and whether it's going to make a big difference to what it's landing on underneath. And when they're at that point where they're just like, please tell us the answer, that's when you've got them. And you go, okay, let's have a look. Oh, isn't that interesting? Everybody was watching. And partner talk can get you to that moment, because if they're just telling you, then only the loud ones are committing to what they think. If they're telling someone else and retelling and explaining and setting up their reasoning behind what they think, then they're sort of invested in what the answer might be. And sometimes I write lots of answers on the board. I tend to get everybody's answers, maybe not the whole class, but a good number. And if the right answer's in there, I don't react. I just treat it like any other answer, and we all become these interested investigators together. So you're sort of standing with the children going, oh gosh, that's interesting. I don't know the answer. You don't know the answer. Let's find out together. And that's key. So lots of talk in the classroom is what I would say, and use your partner talk, and then back and forth with the teacher, and then don't go yes to anyone. Just collect lots of ideas, and they're all just as valuable. And I quite often go, good thinking, even if it's the wrong answer, because they've done some thinking.
Yeah, I like what you're saying there about making sure it's about the process. It's about the way of thinking and building that culture of how you think rather than just getting the right answer. Yeah, thank you very much for that. And then I'd love to go over to Paul now and just ask if there are activity from this whole unit that just builds on everything right near the end for a final unit outcome. What would you suggest?
So one of my favourites is about waterproofing, and it's about how we can change the properties of materials. So we start with just a square of cotton, and it's where most of my old shirts end up when I've finished with them. They get cut up into squares and taken into school. So you start with a square of cotton and you drop water on it, and you observe that the water just drips straight through the cotton. So it's not very appropriate for for an umbrella or for a coat. So how can we change the properties of that piece of cotton and make it waterproof? And we can experiment with lots of different things. We can colour it with a felt tip pen. Does that help? We can colour it with a colouring pencil. Does that help? Oh, okay, it's starting, it's maybe the water's dripping through a bit slower now. We can colour it then with a wax crayon. What impact does that have? And what about if we do 2 layers of the wax crayon on it? And then what happens if we use a wax candle and rub that on it? Or what happens if we rub honey on it or rub sunflower oil on it? And there's so many different things you can try. And you're really getting children to take all that knowledge that they've built up about properties of materials, uses of materials, and you're getting them to really think about how they can then change the properties of a material for a really practical use. And then you can look at the real life, the real applications of this, the fact that actually your coat isn't just a single layer, it's made up of different layers of materials, and each of those different materials does a slightly different job. In my materials box at school, I've got a number of jackets, old jackets, where I've literally cut them in half so we can open them up and see all the materials as they go through. But it's a really simple, really powerful investigation for the children to do that demonstrates how we can take a material that's completely unsuitable and make it suitable for that use.
That's a really good idea. Thank you for that, Paul. And I think something that hopefully the kids will go and try at home, but maybe not with mum or dad's best shirt or best dress.
Well, I've had that complaint from parents before.
All in the name of science. Come on. So, we've been through so many amazing ideas for this unit today, but I would just hate to miss anything. So could I just ask that we wrap up, we finish with one final, very short takeaway each. Dave?
I'm going to say, building on what Paul's just said about his exploration with the shirts, engaging those parents. So actually telling the children to go and look at the materials at home and doing some sort of, I hate to use the word homework, some task at home to find out what materials are being used around the home, so the parents know what the children are doing in school, which is always so valuable, but actually getting them to do some investigating at home to reinforce what's happening at school. And materials is such an easy one to do for that, because there's materials everywhere.
Thank you, Dave. And Jules?
Well, I would say this is a really great opportunity for getting children to do simple tests to answer their own questions. So which is the best for this, which is the best for that, and coming up with ways to do the test themselves. Obviously in year 1 you need to kind of show them how tests work, but in year 2 you could take some of their ideas. Let's try testing it this way. In order to get that going, you have to allow for play first. Now, play is really valued in foundation, really valued, and in year 1, if you're lucky, you're still doing sort of free flow investigations by themselves, and they're doing quite a lot of browsing around lots of different things and getting into their own independent play. But it gets washed out of the curriculum somewhere after year 1, and so allowing them time in the science lesson with the science kit to play and just say, well, let's just have a go, see what you can find out. Oh, you're doing something interesting. Show us what you're doing. Oh, you're doing something interesting. Show us what you're doing. And getting them to inspire each other to the point where they go, well, what happens if I do this? Can I try this? That's the moment where you know you've got them thinking scientifically, is when they come up with their own question. And it may not be something that's easy to test, but I would encourage you as much as possible when you have those moments to roll with it. So I had a big tray, a big tough tray with tall sides, and they'd filled it with water, and we were finding different ways to retrieve things from the water, separating out the different bits and pieces. And this child was convinced that if he threw everything up in the air, that the paper clips and the rice would come out by themselves. And which of course is a big messy thing to do, but at the end of the lesson I went, all right, let's go and try that. We'll try and do that so that we don't get completely soaked. We'll do it on a smaller measure and we'll do it outside, but we'll give it a go, because it's only by testing their misconceptions and letting them see what doesn't happen that they expect it to happen, and when it doesn't happen, that helps to solve it. So play leads to testing out things informally, leads to questions, leads to interesting tests, leads to scientific thinking.
Thank you. And Paul?
I'm going to cheat here and I'm going to throw 3 quick things at you. The first one is about letting children experience natural versus manufactured materials. So get them outside, get them exploring materials outside, get them building with materials outside, and then talk about the comparisons between those natural materials and the manufactured materials that they're maybe used to in school. The second one is about the power of storytelling. And one of the things that fascinates me about materials is how many of these materials that we use day to day were discovered completely by accident. And so telling the story, for example, of how silly putty was invented completely by accident, when during World War II they were looking for a cheap alternative to synthetic rubber, and they invented this substance that had more bounce and stretch than rubber. Turned out the government wasn't really interested in it, but they then just noticed by accident how at a party it was really popular with the kids, and so they renamed it silly putty, and off you go. Play-Doh as well. Play-Doh was invented during World War II as a cleaning product to clean layers of soot deposits throughout the house. But it wasn't massively popular. Turned out it was a brilliant, thing for children to play with and build. Other things like vulcanized rubber, Teflon, safety glass, Kevlar were all accidental discoveries of materials that have turned out to be pretty much society changing in many ways. And then the final takeaway is microscopes, which Dave and Jules will know I'm obsessed with my microscope. But looking at materials under a microscope is endlessly fascinating. So invest in a cheap digital microscope that you can hook up to your interactive board and look at as many materials as you can under the microscope.
And there you go, guys. Key Stage 1, Everyday Materials, is now done and dusted in the best way possible. Please do join us for the next episode in March, where we will stay with materials, but jump up the school into things like states of matter and changes of materials in Key Stage 2. So a huge thank you to Dave, Jules, and Paul for coming on the show and sharing so many of these practical ideas. You've all been an absolute pleasure to host.
Thanks for
It's been
having
lovely
us.
to be here. Yeah.
Thanks very much, Tim.
Amazing. Thank you very much for listening, everyone, and see you next time on the Primary Science Podcast. Bye for now.
Bye-bye.
Bye.